Okay, so we're going to be going over 2.5, which is b there or b square. Okay, I forgot to label it here. So we're going to be able to use completing the square to change the form of a quadratic equation. Okay, and then we're going to graph quadratic equations given in standard form. And how might completing the square help us to graph parabolas? Okay, so completing the square, which we were doing in 2.4 and 2.4. The whole purpose of completing the square is to not complete the square. That's not the point of it. The whole point of completing the square is to get something to look like a better form of its own self. Does that make sense? So for example, so if we were given something like in this form right here, if I asked you, okay, guys, now graph it. Now you guys did a fantastic job on these ones here, right? Like, look at all my great parabolas, look at all my great parabolas. And then if I scroll down, there'll be even more. I have people that are being really, really precise with their parabolas. So if it's in this form, I can graph you a graphing calculator, a parabola relatively quickly. But if it's in this form right here, it's a little bit more difficult. Okay. It's a little bit more difficult. Okay. So let's go through these. So again, here's that context that we talked about earlier. She's working and then she's like, oh my gosh, this kind of looks like my homework. And then you go in there even more. And then she's like, okay, but this equation here, y equals x minus 3 quantity squared plus 4. And she's like, that would be the length of the standard square. And it's reduced by 3. And then we add a little piece of fabric that has the area of 4. We don't usually get orders like that, but it still makes sense. And then so here, I wanted you guys to fully describe that what the parabola that Jenny has been assigned to graph. So I got really good descriptions. I'm just going to look at your descriptions instead of mine. It says the parabola's vertex is at 3, 4. Awesome. Very good. And again, it's right here, 3 and 4. And some of you are like, Ms. Johnson, isn't it negative? But remember, what do we know about X? What do we know about X? Yeah, he lives in backwards land for some reason. He doesn't listen very well, and that's good, right? And she's like, that's funny. This would be in order, blah, blah, blah. Okay, so then this person also says the parabola is shifted to the right 3. I agree with that. And then up 4 units. Perfect. The parabola is also facing upwards, like opening upward. It looks like a U, and it has a y-intercept of 0, 13. Okay. The y-intercept part, kind of important, but it's not like, oh my gosh, I have to know that. The biggest thing are these things: shifted right 3, up 4. It's opening to the top, and the vertex is at 3, 4. Y-intercepts are important, but probably not in, this little area here. So does that make sense? Okay, next little slide. Then it says, Jenny returns to her homework, which is about graphing quadratics. Ugh. Much to her dismay, she finds out that she's been given this equation. She says, oh dear, I can't tell what the vertex is or identify the transformations on the parabola in this form, right? So it says, now what am I supposed to do? And she's like, wait a minute, is this the area of a perfect square? So what we're going to do right now is we're going to build, right, let's get you over. We're going to try to build this as a perfect square. So that's what this is here. So I'm going to use this. I'm just going to make it bigger. And then we're going to try building a perfect square. Okay. So first of all, it says, hold on a second, let me grab this. First of all, it says, okay, so now we want to build this we want to build this. Okay, so how do we rewrite x squared minus 6x plus 9? How do we do that? So how did you guys do that? Actually, I want to go over here. How did you guys do this? What's happening in my over here? Okay, so let's see. Oh, yeah, I haven't gotten it yet. Oh, yeah, right here. Okay, so one of the things that I do is I looked at this and she says, now pay attention to the details here. She says, I think I figured this out. No, over here. Wait, is this the area of a perfect square? Is this the area of a perfect square? So if you can build this for me, remember we were building these with like little things, little squares and rectangles and stuff. So let's build that. This is going to be negative 6x. So just know that I'm using like negative x's as opposed to positive x's. So let me draw this out really quick. Remember we were doing this? So here's x squared, looks like this, right? Here's my x squared. And then it says negative 6x. What does negative 6x actually mean? Do you guys remember this? What does negative 6x mean? Slide 7, I think so. Yeah, no. Slide 7 is the same as slide 8. Slide 7 is very similar. So what I'm going to do is I'm going to do slide 8 along with slide 7. Okay. So what are these negative 6x's? What do they look like? Do you remember what they look like before? Yeah, they look like little rectangles. So let me go grab rectangles. Let me change the color. Maybe blue. Let's do these blue ones. So I go like this and I go. That looks kind of good, right? It's a little long. That looks pretty good. That's as good as I'm going to get right now. Okay, so I have negative 6 of them. How many of them am I going to put right here? How many am I going to put on this side right here? Yeah, 3 on each side. Very good. So, okay. So I'm going to put 3 right. Do you guys remember this? And then I'm going to draw 3 on the other side right here. Right. And then how many of the little squares are we going to need to fill up this little area here? Yep, I'm going to need 9. And I'm not even going to draw them in. I'm just going to go 9, just like that. Everybody okay with me? Everybody still with me? Very good. Thank you so much. Okay. So does this represent a perfect square? And you will all say, yeah, it represents a perfect square. Okay. So then how long is this side? How long is this side? Now remember, these are negatives. So I'm going to put a little negative in here. Negative, negative. Okay. That's how I'm going to denote negatives from now on. Just putting a little negative in there. So how long is this side? Do you guys remember how to tell how long is this side? Yes, but not plus 3, right? This would be x minus 3. And this would be x minus 3. You guys all see my x minus 3? Because look, I have 3 negatives. Very good. Okay, good. So Ms. Johnson, so one of the new forms of the equation is I can write it like this, x minus 3 times x minus 3. Everyone's okay with that? Yes, remember I told you guys I want every single person participating. So get in here, get in these answers. Very good. Okay. So is there another way that I could write this instead of x minus 3 times x minus 3? Is there another way that I could write this? Is there another way that I could write this? No, not 2 of them. It would look like this. X minus 3. Remember, if you have x minus 3 times itself, what does that times itself mean? Times itself. What is that? Yes, look in the chat, everybody. Squared. Very good. Very, very good. So times itself is squared, not 2 times, right? Not 2 times. Very good. Thank you so much for participating in that. Really, really good job. Okay. So that's my new equation. Y equals to x minus 3 quantity squared. So I'm going to put a y equals on this side. So is everybody comfortable with this? Everybody see how we went from here to here. So here, this one says, it says, use your work from this lesson to prove her answer. And we just did that. So all of this work can go up here, right? And then it says, write the vertex of this parabola. Okay, so do you see how here If I say, okay, guys, tell me my vertex, you're like, crickets, right? But over here, if I said, okay, guys, now I'm going to write it out. So just so that you could see it a little bit better. So if I wrote it out like this, y equals to x minus 3 quantity squared, what would my vertex now be, right? What would it be now? Now, for those of you who are like, oh, Ms. Johnson, I get how to do this. Where is this shifting? Very good. Very, very good. Okay, I need some more people with their answers. What does this 3 do to my whole parabola? Yes, it shifts it which way? To the right or to the left? Yes, it shifted to the right. Okay, good. If that's the case, right? And imagine my normal x squared guy is right here, right? My normal x squared guy is right here and it's 0, 0. And I shift it and I shift my parabola over. What would the new vertex be? What would the new vertex be? You got to give me 2 numbers because it's a point, right? You can't just give me like 7. It's got to be 2 numbers. So is it 0, 3? 0, 3 looks like this. Let me go grab this guy. Is this the point you mean? 0, 3. Let me go back home. Let me turn these guys off. You don't need exponentials for this. Is that the point that you meant? Oh, yeah, fix it. It's 3, 0. Okay. So it's 3, 0. Okay, where do you see 3, 0 in your function? Where do you see that? Where do you see 3, 0? Remember, this is what we talked about last time. Where do you see 3, 0 in your function? No, in your function right here. Where do you see 3, 0? Do you see it? So you would see it if I put this as this, right? Do you guys all see my 3, 0 now? There it is right there, 3, 0. Remember, that's what our buddy over here said. Where is it? Yes, this one, and then this person said, remember, 3, 4 matches with 3, 4. Remember, that's what we said earlier. So do you see your vertex here? Yeah, so guess what this guy's name is called? His name is called Vertex Form. Vertex Form, why do you think this guy is called Vertex Form? Because I see the vertex, Miss Johnson. Exactly. Does that make sense? This guy is called standard form when he's all like x squared, x, all that. So here, you graphing it should be okay. Let's see. So if I sketch it super quick. 3, 0 is my point. You guys like to do the line of symmetry. Very good. And then I would just plug in a couple of points and then mirror them across. So when I plug in 4, is it easier, you think, to plug in here or here? If I was plugging in 4, is it easier to plug in here in vertex form or here in standard form? Come on, y'all. If I plugged in 4, would it be easier? Would you want to plug it in here or here? Yeah, in vertex form, right? Vertex form is way easier. So Ms. Johnson, why was it easier on vertex form? Because look, 4 minus 3, that's 1. 1 squared is 1. See how much easier than, okay, 4 squared is 16 minus 24 plus 9. You see how much work that is versus that? Okay. So then I just put with at least 3 points on each side of the line of symmetry. Okay, fine. Let me plug in 1. 1 minus 3 is negative 2 squared is 4. So 1, 4, oops. 1, 4. Let me mirror him over here. If I plug in 0, it's -3 squared, which is just 9. Okay, so there's my parabola. You guys all see it? Again, we don't be fancy. We don't make it a V. It's just a curve. Doesn't have to be perfect. Just make it go up some more. Okay, so there's my parabola. Questions on this? Okay, so let's do one more. It says the quadratic to the graph Jenny's homework is y equals x squared plus 4x plus 2. Does this expression fit the pattern of a perfect square? If I built out my squares, looking at this, would this make a perfect square? Would this make a perfect square like this one did? What do you guys think? Yes or no? So do you want me to build it? Do you guys remember what we're doing? No, we don't. Okay, so let's build x squared plus 4x plus 2. So what does x squared look like? What color is it up here? Come on, y'all. We got to move on. What color is x squared up here? No, that's not. The rectangles are not x squareds. Yeah, which one is x squared up here? Yeah, the pink one. So grab a pink one, Miss Johnson. Okay. I'm building x squared plus 4x plus 2. So x squared. And I'm asking, is this gonna be a perfect square? Okay, now I need 4 x's. Oh, okay. Sounds good. Yeah, Alexa says, no, Ms. Johnson, it's not gonna build it. So your job is to figure out, why do you not think it's gonna make it? Why don't you think it's gonna make a perfect square? Here's 4 x's. I'm gonna erase those little guys in the side inside. Okay, I'm gonna make them positives. Actually, that's what I should have done. I'm building it slowly so you guys can catch up with me, or catch up to your classmate who said that. So is this going to, that didn't catch up. There you go. Is this gonna make a perfect square? And if you say yes, why? If you say no, why not? Why isn't this gonna be a perfect square? There. I'm gonna make a plus plus in a second. Do you guys all see? My iPad is not catching up. Okay, so continue on with me. Imagine 2 little squares here. Would this make a perfect square? Would this make a perfect square? Oh no, I stole them instead of copying them. Just put those back over there. Okay. Okay, so why isn't this a perfect square? How many would I need here to make a perfect square? Good. How many do I need here to make a perfect square? Everybody needs to tell me this. Yeah. How many do I have though? How many do I have? Yeah. I don't have 4 to put here. I only have 2. So, okay. So I really want 4, but I don't have 4. I only have 2. So when we were completing the square, the way we'd rewrite this is we'd go, okay, well, this is going to be x plus 2 and x plus 2. How do I write this How do I write this as a thing? Yeah, kind of, Nathan. Good job. So how would I rewrite this as an expression of area? How long is this side up here? No, be really careful how you write this. How do you write this across the top? How do you write this across the top? Yes, x plus 2. Very good. So this is x plus 2. How much is this? Okay, so everyone stop right now because I got a lot of wrong answers and I want to make sure that we're all good. When I ask the length of this up here, I'm asking how long is it? Well, this is x long and this is 1 and 1. So this whole thing right here is x plus 2. Is everybody comfortable with x plus 2? Everybody's okay with x plus 2 because I got a lot of weird answers. Down here is the same thing. Now, I want you to write this area. How would I write this area? This area here, not this one, this one. No worries. No worries. Yes. Oh. What I wanted. Oh, where'd it go? There it is. So this is what one of your classmates said, right? Oh, wait, not this plus 2, just this part. Just look at this part. So don't look at this plus, this extra plus 2, just ignore him. So this is x squared, x plus 2 quantity squared is equal to x plus 4, x plus 4. Ignore this plus 2 for now. I know what you're trying to do, but just leave it like this. So does everybody see x plus 2 times x plus 2? Does everybody see that? Okay. Does everybody see x squared plus 4x plus 4? Does everybody see that? Do you see why they're equal? Wait, you don't see which one? You don't see the x squared plus 4x plus 4? See, it's all right here. X squared plus 4x is 1, 2, 3, 4. I don't do the little squares anymore just because it takes too much time. Okay, so then what I want to do is I want to compare this to this. This is the thing that I have. Okay, so I don't have x squared plus 4x plus 4. I have x squared plus 4x plus 2. So what happened from here to here? What happened from here to here? What happened from here to here? So how did you go from x squared plus 4x, not 4, but 2? What happened? What math operation needs to happen from here to here? Yeah, you subtract 2. Okay, so because I subtracted 2 on the right side of an equation, what do you have to do on the left side of the equation? Yeah, the same thing. So subtract 2. Okay, so then you want me to write x plus 2 quantity squared minus 2. You want me to write x plus 2 quantity squared, that's what that says, minus 2. Why did I subtract 2? Not plus 2, we're subtracting 2. If you add 2 to this, you would have 2 extra little squares here. Do you want 2 squares? Yeah, you always go from perfect square to your equation. What did you do from your perfect square to your equation? Right? So here's my equation. So wait, Ms. Johnson, you're saying that if this thing here and this thing here are exactly the same. Yes. So do you guys all agree that this part here, x plus 2 quantity squared, is all of this stuff is all of this right here. Yes. You guys all see that? And you have to subtract 2. Exactly. You have to subtract 2 because they didn't give me 4. They only gave me 2. So then I gave much too much. Remember we talked about this. So if we put much too much, then we have to subtract to get rid of that excess. So here's my equation. Okay, so I need to vote. This guy's name is Vertex. This guy's name is Standard. Okay, on the quiz that's on Thursday, which equation would you rather graph? Vertex or Standard? Which form would you rather which form would you rather graph? Yeah, Vertex. Why, Miss Johnson? Well, you tell me. Can you graph this one? Do you guys all know what happens to this graph? And I'm just gonna say, yeah, because look, you guys all did it for the jumpstart. See, my jumpstarts look really good because that's in vertex form. Ms. Johnson, so in standard form, can we still graph it? Yeah, by getting it into vertex form. You get what I'm saying? So standard form is not as useful as vertex form when graphing. Standard form is not as useful as vertex form when we're graphing. Does that make sense? Okay, well, let's go through it. Complete the square, we did it. Is the equation you have written equivalent to the original equation? So are these two things equivalent? Yes, right? And then last but not least, it says identify the vertex. Can you tell me what the vertex is here? What's the vertex? Yeah, it's -2, 2, right? So the vertex is -2. Why does the x go opposite? Why is the x always opposite? Because he lives in backwards land. No different. -2, -2. I think I said it wrong. -2, -2. Okay, so -2, -2. Is everybody comfortable with -2, -2? Everyone comfortable with -2, -2? Very good. Okay, and then graph the parabola with 3 precise points. You all know how to do that. I'm not going to do that. You're comfortable with that. So what I want to do is move on to the next one. Give me a second.